All right, so this chart that you're finishing writing down, I'll also post it. Everything I give because of the remote learners, I'm going to post on Google Classroom, pretty much everything. When I make a video, I'm going to mostly, not every day and not always your class period, because there's a period 6 advanced physics as well. I'm going to record one of you two guys with instructions almost every lesson, if possible, if it works right. So if you're ever absent or anything or miss class, at some point, it takes a little while to upload them, but at some point, maybe not immediately right after class, but hopefully by the end of the school day, if not by the end of the school day, by the end of the day, like the lesson, if I taught anything new that day, will be up on Google Classroom, and you can go watch it if you miss class for any reason. That's my plan anyway. And for everybody at home, that's at-home learners right now, that's how I'm going to do everything for you guys. All right, so anyways, looking at this chart as you finish writing it down, remember a couple quick things from yesterday. Let me make this full screen here. There we go. The metric system is such a better system of measurement compared to the English Standard System because of one major fact. It's based on the tens, all right? And that's what our number system is based on. That's why we can move that decimal like we were yesterday. But for some of us that maybe didn't remember all the prefixes in the order they came in, this chart will help you with that. All right, this is not a comprehensive chart. It doesn't have every prefix. There's like a billion prefixes. But in mechanical physics, 99% of the time, we won't need any bigger than the kilo prefix and any smaller than milli. At some rare times throughout the year, there might be some other ones that aren't on this list. We'll talk about them when we run into them, all right? Some of these are very rare ones that are on this chart because since it's based on tens, you just can't skip to another one. There has to be names for them in between, like hectodeca and even deci are ones you're not going to see applied in here, all right? Or most places very often, but they're there. We might use them just for some quick example ones today. So anyways, I'm going to add two things to this, two arrows that'll just help as well. I'm going to make an arrow that's pointing up on this one and down on this one, which means if you have to move and convert to prefixes that go up the stairs, we move the decimal to the left. If we have to convert and move the prefixes if we go down the stair chart to do that, we move the decimal to the right. This basically does take the math out of it, but you still understand the math, all right? Every step, because of the nature of the system, is going to be worth the power of 10. And that's going to make it real simple. All right, so everybody got that written down? The base unit is in the middle, right? So that could be ones we gave as quick examples yesterday, grams, liters, meters. Anything metric that does not have a prefix on it is considered a base unit. There'll be plenty of other base units we'll learn this year. All right, so with that in mind, we are going to... I'm just going to make up a couple simple examples. All right. So let's say we have something like 36 millimeters, and we want to go to meters. So using that chart, many of us will already know the answer, but just in case any of us are rusty on this, using that chart, we start at milli, right? And we want to change it to meters, which is a base unit, right? How many steps away is meter, the base unit, from milli? Yes. 3 steps away. And I'm going from here to there. That's up the stairs, so I'm going to move the decimal point to the left. Make sense to everybody? And that's simply all we got to do. And as we noted yesterday, if we run out of room and run out of numbers, we just put zeros there. So if we do that and accomplish that, remember if the decimal's not showing, it's right there, right? So what's my answer based on that? Go ahead. Yes. Or in other words, 0.036, right? Meters. Simple enough for everybody? This is just we do this the first day or two just because all through the year, you're going to here and there run into, when we do problems, metric prefix to prefix conversions. It's going to be fairly frequent, and it should be like something you just do like that, basically. But that stair chart, if you forget the order of the things, will help you. You could always look back at it. Let's just do like maybe 2 more quick ones. Let's say we want to go from, let's say, 48.2 grams, And let's say we want to go to, by the way, if my screen ever shuts down, I'm not looking back at it. It happens sometimes. Say something to me so I'm not just writing up here and you're staring at a blank screen. I don't know what I just did right there. 48.2 grams, and let's say we want to go to centigrams. Use that chart. Somebody tell me the answer. Go ahead. 4,800, and I think you know the right answer, just not saying it right. Basically, we move the decimal place. How many places? 2 to the right. So 4820, right? And that's it. So grams to centigrams. Let's throw in one more. Everybody with me? Any questions? Okay. Hopefully this is pretty easy. Let's say we have 38 kiloliters, and we want to change that to blank milliliters. Kiloliters to milliliters. How many places and what direction? How about somebody else that hasn't answered yet? How many places and what direction? Go ahead. 6 to the right. So since there's no more places left, that's 6 zeros we tacked on, which would be 38 million milliliters. That concept builder we were looking at on yesterday that I was using to do these on, I'm going to assign you some of that on Monday in class. They should go quick. And by the way, speaking of that, I think we are going to get the paid version of it at some point this year. Because I looked into it, and it's not very expensive, so I think they're going to get it for us. But until then, we can still use it as guests like I was showing. I'll talk a little bit more about that on Monday, how you turn that in when you do the first one. All right, so pretty easy. There's one other type of conversion that you'll be responsible for that's not hard, but more complicated than this. This, you could only move the decimal to convert when you have, the only thing you're changing is just a single prefix, okay? When you have what we call a derived unit, we have to use a process called the factor label method that you're probably already familiar with, even if that doesn't sound familiar to you. I'll tell you why in a second. Let's write this down, and we'll show an example or two of this today, and maybe work on a couple on Monday. So just title this little spot underneath your chart. The chart is still going to help us if needed, but we can't just use it to move decimals, okay? How many of you remember, did everybody in here have it like at least advanced chem? Probably. That's all right if you didn't, but I'm just using this as an example. You might remember doing some big ugly conversions when you did stuff with moles. Does that ring a bell? Where maybe you had to convert something, you put it up top here, put it at the bottom here, they canceled out. Does that kind of sound familiar? If it doesn't, don't worry about it. A lot of you might know this process because of that. If you don't, it's still not hard. Just follow along if you never saw anything like it. Where we use this the most is when we get to speed and velocity, and even acceleration. But speed and velocity units in the metric system, the two most common ones we run into are kilometers per hour and meters per second. And a lot of times we have to convert from one to the other. But we're not just going from kilometers to meters. Each of them, a derived unit has like two or more parts to it. They both have a per hour or per second, right? So when there's that like locked into it, a unit mathematically, you can't get away with just moving a decimal, right? Like when we're just changing only a prefix. So we kind of use this method, and once you get good at it, you probably could basically do it in your head or write in your calculator. But until you get to that point, this is a nice drawn out way that keeps track of it so you don't mess it up. So I'm just going to make up value in kilometers per hour that we want to change to meters per second. So I'll say, I don't know, 52 kilometers per hour. And there's different ways to visualize this and show it, but I usually set it up looking like almost like a bridge. All right. Once I know that I can't just convert using the little bouncing the decimal place thing, I'm going to make a little bridge starting like this. I'll leave it open. I'm going to put a line here. All right. This just separates converting one unit at a time. In this particular example, we need to convert 2 units, right? Kilometers to what did I say? What did I want this to go to? Yeah. Meters, and hours to second. All right. We can only do one of those at a time. Otherwise, we'll probably make a mistake unless you're pretty slick at this and do it a lot, okay? So we're just going to use some basic rules of math and algebra that should be pretty common sense by now. If I don't want kilometers in my answer, so I need it to cancel. Kilometers is up top. To mathematically cancel kilometers in a fraction, if it's up top, it also has to be where? To cancel. On the bottom. Leave a little space here for a number, conversion number to put in, but we got to put it there. So in a moment, that will cancel since one's on the top and one's on the bottom. And we wanted to turn the meters up top, right? So here is where the stair chart will still help us if necessary, if you don't already know this. We can't just bounce a decimal, but we could use it to know the numbers I plug in here if you're not real slick at this. So how many steps is kilometer away from meter? Yes? Look again. Go ahead again. 3, right? 3 steps. Remember I said earlier, each step is worth a power of what? 10. So 10 times 10 times 10 is going to be the conversion factor. And 10 times 10 times 10 is what? 1,000. Just write it in the right spot. There's 1,000 meters in 1 kilometer. Don't write that backwards. Because we all should at least know generally a kilometer is a pretty big distance, right? There wouldn't be 1,000 kilometers in 1 meter. A meter's about that big, right? So make sure you put it in the right order there. And if that's all we had to do and that's it, we could have just bounced the decimal. All right? But because we have to convert this hours part, it wouldn't work out mathematically right and real by actually just bouncing the decimal. So now that's going to take care of those kilometers. Will cancel out. Now let's worry about the next part, then we'll run the numbers. Hours is on the bottom, so to cancel it needs to go on the top, right? Seconds is what we want to go to, become on the bottom. We want to end up with meters per second. Now we need a conversion one. Quick without thinking. Somebody tell me how many seconds are in an hour. Go. Nope. I got, yeah, that's why I said quick. I always get everybody with that, yeah. 36,000 you said? 3,600. Now here's the thing. Most of the time, somebody always yells at 60, don't feel bad. That's why I say it quick. Most of the time for just everyday use, we all know our time stuff because that's something we're used to. But you never normally have to go from hours to seconds. A lot of times we go from hours to minutes, minutes to seconds, right? You usually don't just commonly make that jump. So that's why very few people answer that correctly when I say that real quick. So because barely anybody probably knew that right off the top of their head, just a little note for the rest of the year, I'm just going to put it down at the bottom. We need to remember that. There's 3,600 seconds is the equivalent of 1 hour. That's the conversion rate, the direct one. Now, if you didn't know that, we could have went from hours to minutes to seconds, but that would just take an extra step. Then you still would have got 60 times 60, and that would have still been 3,600. But why not go in the condensed step and know that all the time, right? So remember that and know that. Bless you. All right, so now we put that in. Again, don't write this backwards. Nobody better tell me that there's 3,600 hours in 1 second. All right, if you're thinking about what you do, you should not make that mistake. That somewhere, somehow, every year, somebody does it all the time. All right, not that I think you would think that that's really the case, but when you do stuff mindlessly and don't think about it, mistakes like that happen. All right, so now the hours have canceled there. What we should have left, the only units we should have remaining that didn't cancel are the ones we want left, meters over seconds, right? Now we run the numbers, and I'll just run them quickly for us here today, and you'll do a couple practice ones of these yourselves on Monday. So 52 times 1,000 up top, which is just going to be 52,000. And there's only 3,600 on the bottom other than 1, so that's divided by 3,600. And that'll be 14.4 meters per second. Did I talk about significant figures at all yesterday in here? Did we discuss that at all? Okay. You don't have to use them this year, but at the end of the year, we will learn about them for future use in courses where you got to use them. If you get, like I actually got like 14.444444 in my calculator. I don't want a million decimals in your answer if there are on your calculators, okay? Since we're not using sig figs or required to in here, round to 1 or 2 decimal places. That's what I always say. All right, so you could easily see that this is the correct way to do it, and there's no way I could have got that answer by just moving a decimal, right? So one more time, only ever correct or convert that way of moving the decimal if you're only going to change in prefix on the same unit without any other parts to it. Otherwise, you got to do something like this, okay? And Monday I'll give you a backwards one where you have to go from meters per second to kilometers per hour, but everything just basically flips. That's the most common one you're going to have to use this for, basically throughout the year. And it happens frequently enough that that's why we do it early on, so we're all on the same page when we run into it the first time. Any questions on any of that? All right, I can't imagine there's much time left. So I'm going to stop there today. No homework over the weekend. You'll do a few practice ones in class on Monday before we move on to the next thing. Have a good weekend, guys. Thanks.